Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. There are 10 squares in total, so each square is worth 1/10. And if we count all of the shaded squares, we notice that in total there are 7 shaded squares. So that's 7 lots of 1/10 or 7/10. For us to create the largest number, we need to pick the biggest digits for the start of the number. So the biggest digit is 7, then 6, then 4, then 3. But the question says it wants the largest even number, so we need to just swap the last two around to make sure that it is even. So our answer is 7,634. In this question we're given the output as 53, so we know that the output was 53. So now we've kind of got to work backwards. And when we work backwards through a function machine or a number machine, we do the opposite of what it says. So this first one says +9, but when we go backwards we do the opposite, which is take away 9. So we do 53 take away 9, which is 44. Now we can check that by going the other way, so 44 plus 9 is 53, so that works. The next one says times 4, so the opposite would be divided by 4. So we're going to do 44 divided by 4, and that gives us an input of 11. Now let's check the whole thing. We put in 11. 11 times 4 is 44. 44 plus 9 is 53, so we know we've got it correct. If we write in how many sides each shape has, triangle has 3, quadrilateral 4, pentagon 5, hexagon 6, you'll notice the number of vertices is twice the amount of each of them. So if a shape has 15 sides, we just times that by 2, and it will have 30 vertices. So 55% is the same as 55 over 100. And what I can do is I can divide top one of the fraction by 5. And so that is going to equal 11 over 20. Now in total there are 20 squares here, because there's 5 across and 4 down. 5 times 4 is 20. And if there's 20 squares and we're looking to shade in 11/20ths, it's just going to be 11 squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what we do is we notice that to get this 10, we add the 3 and the 7. To get this 17, we add the 7 and the 10. And to get this 27, we add the 10 and the 17. Whenever we have this kind of sequence, it's called a Fibonacci sequence. You essentially add the previous two terms to get to the next term. And so what we need to do is just simply add the 17 and the 27. When you do that, you get 44. So our next term is 44. To answer this question, we need to cut this shape into 2 shapes. So we're going to draw a line across here, and we're going to cut it into a rectangle and a triangle. Now we need to first of all label the parts of the triangle. So the length or the width of the triangle, the base, will be the same as the base at the bottom, so that will be 20 centimeters. And we need to find the height, which is this length here, which is 90 degrees to the base. And to find that, what we can look at is the fact that the total height of the whole thing is 13, and the height of the bit we don't want is 11. So what's left over? Well, 2 centimeters will be left over, so the height will be 2 centimeters of the triangle. So let's work out the area of the triangle first. which is going to be half times base times height. Half times the base, which is 20, times the height, which is 2, will just give us 20. Now let's work out the area of the rectangle. And that's just going to be the width times the length. Width is 20, the length is 11, so that would be 220. Then to work out the total area of the whole thing, we're just going to add those together. So 220 plus 20, which is 240. The units are all in centimetres, and so the area units will be centimetres squared. So to draw this straight line graph, what we're going to do is just pick 3 x coordinates, which is -2, 0 and 2. So I'm going to start off with -2, and I'm just going to substitute it into the equation we've got here. So y equals -2 times -2, because that's what we're putting in, plus 8. -2 times -2 is +4. So it's going to be 4 plus 8, which is going to be 12. So at -2, our graph is at 12, which will be here. Then we're going to put in x equals 0. So it's going to be y equals -2 times 0 plus 8. Anything times 0 is just 0, so it's just going to be 0 plus 8, or just 8. So it's going to be 0, 8 will be our next coordinate. And then finally we've got x equals 2. So it's going to be y equals -2 times 2 plus 8. -2 times 2 is going to be -4. And -4 plus 8, which is the same as 8 take away 4, so that's going to be 4. So at 2 it's going to be 4. So we get our ruler to be able to draw this in. We try our best to make sure it's as neat as we can, and make sure it continues on for the whole graph, so no gaps. A sample space diagram is basically a diagram that shows all the outcomes, and we've got the outcomes from spinner 2 at the top, so either 1, 2 or 3, and we've got the outcomes from spinner 1 down the side, so A, B, C, D or E. And we're just writing down all the combinations. So this will be A2, A3, and then this will be B1, C1, D1, E1, and this will be B2, C2, D2, E2, and this will be B3, C3, D3, and E3. And this represents all the possible outcomes you can get from both spinners. So here we have a back-to-back stem leaf diagram, and we're going to focus on just the girls first, because the right-hand one is normally easier to do. So the stem here gives us all of the tens by the looks of it, and then we put the units in here. So we've got 102 here and 105 here, so we're going to put a 2 here and a 5 here to represent 102 and 105. Now they go from biggest being the right hand side and the smallest being nearest the middle. We've got a 90, 92, so 90 and a 92, and we've got a 73 there. And the key we can have for the girls is just 7 line 3 is 73 hours. It doesn't actually matter which value we pick. We could actually pick a value that's not on there, so 6 line 3 equals 63 hours. It's just a way of showing that that 7 represents a 10 and not a unit or anything else. Okay, so we're going to do the boys next. I'm going to pick a different colour. Now the boys gets tricky because it's actually the smaller numbers go in the middle. So when we look at 72 and 76, the order will be actually the 2 first and then the 6. Then we've got 80 and 81. So it'd be 80, then 81, and then we've got 93 there, so the 3 will go there. And the key's a bit weird as well, so if we look at this part here, it's 2 line 7 there, so let's copy that down, so 2 line 7, but that actually represents 72, So it's kind of the other way around. So the left-hand side of a stem leaf diagram can be a little bit confusing. Just remember that the smaller numbers go in the middle and the biggest on the outside. So on the left-hand side, the biggest will be on the left-hand side. A plan is a view that you would get if you were on top of the shape. So you were in an airplane or something looking down on the shape. So the sides of this that we'll see, well, we'd see this bit here, and we would see this bit here. So I'm going to start off with the first bit I shaded, and we've got to figure out what the different lengths will be. Well, this would be 2 centimeters across, and the whole thing is 8 centimeters. The bit we don't want is 3 centimeters, so this part here will be 5. It would look like it was 5 wide. So let's draw that on, and so we've got 2 centimeters down, and we've got 5 across. 1, 2, 3, 4, 5. And this is what it would look like from above. Now the other part will be same 2 centimeters, but it will be 3 centimeters across. So we have 3 centimeters across. Now whenever you have a join or a change in elevation, you need to show that with a line across, and so this will be our completed answer. To find the area of a parallelogram, we use a simple formula, which is the area is the base times the height. Now the base and the height must hit each other at 90 degrees, so this length here is not counted as the height because it doesn't hit the base, which is here, at 90 degrees. The height is this length here, and the base is either this length here or the length at the top. It doesn't matter because they both hit the height at 90 degrees. So we're going to do the base, which is 11, times the height, which is 3, and that gives us 33. Now both of the base and the height are in centimeters, therefore the area will be centimeters squared, 33 centimeters squared. So I'm going to start just by writing out the equation, and I can put my lines in. Okay, we're asked to make x the subject, so we're going to first of all add 10 to both sides. In fact, I'm just going to move all this over a little bit so I've got a bit more space. Okay, so we're left with m plus 10 on the left hand side, and we've got 1/7 x on the right hand side. Now to get rid of the 1/7, what I can do is just times both sides by 7. So 7 brackets m plus 10 equals x. So x therefore would equal 7 brackets m plus 10, but it says expand your answer fully, so we're just going to expand the brackets. 7m plus 70. To find out what the value of x is, we first of all have to find out what the value of y is. And we can notice that we've got 2 sets of parallel lines here and here, and a line going through them. And we kind of got these f angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78. And we must write down the reason, so corresponding angles, and corresponding angles are equal. Now here we've got an equation and we want to solve it, so we get our lines in. We'll go first of all add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides, or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also two parallel lines, and we've got this angle here and this angle are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180, angles in a triangle, take away the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. So for us to work out the average speed, so we've got to first of all remember the triangle. So average speed is total distance over total time. And we're told to find the average speed before stopping. So stopping is shown with a horizontal line on a distance time graph. So it's up to this point here. So the average speed will be the total distance, which would be 20, over the total time. So 9:30 to 10 will be 30 minutes, but since our unit will be kilometers per hour, we need that in hours, which will be a half. And 20 divided by a half is going to be 40. So our answer is going to be 40 kilometers per hour. So we know that James knows that he has a square. So we can actually get rid of all of this bit. It's not relevant at all to the question. And the question asks, what is the probability that the square is blue? Well, there are 3 blue squares, so it will be 3 over, and how many are there in total? Well, it says the total is 17. So the answer is 3 over 17. Something we know about rectangles is opposite sides are equal. So these two will be equal. And these two will be equal. And you notice now that we've got simultaneous equations. So what I'm going to do is get the coefficient of the y the same. And I'm going to do that by multiplying everything in the second equation by 3. So we get 6x plus 9y equals 123. And I'm just going to write in the first equation underneath, because with simultaneous equations we work downwards. Now looking at the signs, they are the same, and the s in same is the s in subtract. So we're going to subtract going downwards. We're just going to subtract going downwards. So 6x take away 3x is 3x. 9y take away 9y is nothing, which is good. That's what we need. And then 123 take away 93 is 30. We're going to get our solving lines in, and we're just going to divide by 3 both sides. So we've got x equals 10. So we know what x is, but we need to find out what y is. So what I'm going to do is I'm just going to pick one of the equations. I can pick the 2x plus 3y equals 41, and just substitute the value of x in. So 2 times, instead of x, it's times 10, plus 3y equals 41. So it would be 20 plus 3y equals 41. Get my solving lines in. And we're going to take away 20 both sides. So we've got 3y equals 21. And then we're going to divide by 3 both sides, if I don't run out of room. So y equals 7. So we've got x equals 10, y equals 7. Now I could check that with the first equation as well. So 3 times 10 is 30, 9 times 7 is 63, 30 plus 63 is 93. So we know we've got it right. The surface area of a sphere is found with the formula 4 pi r squared, with r being the radius of the sphere. So we're going to do 4 times pi times the 20, and that gives us 5026.548 blah blah blah. And when we round that to 2 decimal places, we get 5026.548 26.55 centimeters squared. I'm going to draw out the two triangles that we have here just separately, and so we can see a little bit clearer about what's going on, and it's actually good advice to actually draw them separately. And so here we've got AB, which is, if I get off that mode, 33 meters, and so this is AB, and this other triangle is ADE. Should probably have labelled that on. And we've got the 91 there, and we've got 13 there, and then we've got 147 here. I think that's all. And we're asked to find length AD. So the first thing to notice is that these triangles are similar, and the way we know is that this angle and this angle will be equal, because on the original diagram you can see that they make an F, which means they're corresponding because we've got the parallel sides. Same with these two angles, they're going to be corresponding for the same reason, and this top one is a shared angle, so they're going to be equal on both diagrams. When you've got two triangles that have equal angles, they're definitely similar, so one's an enlargement of the other. If they're similar, it means that we can find a scale factor. And so what I'm going to do is just find a scale factor between the 13 and the 91. To do that, we do the big number divided by the little number, and that gives us 7. So the scale factor is going to be 7. And we're going to work backwards with the scale factor, and we're looking for length AD, which is this length here. And so we're going to do this one, and we're going to times it by the scale factor. So times it by 7 to find out what the new length is. So 33 times 7 is 231. So we notice with these simultaneous equations that the coefficients of the x's are different and the coefficients of the y's are different. But if you look at the coefficients of the y's, they are similar. If we multiply the 4 there by 3, we will get to the 12 there, and we ignore signs. I know it's a minus 12. So what we want to do is multiply everything in that equation by 3. So it's going to be 2x plus 4y equals 20, and we're just going to put our lines in, because what we want to do is multiply everything here by 3, and so we get 6x plus the 12y equals 60. And I'm just going to write that out again, so we can put in our simultaneous equation circles, and I'm just going to write the second equation again underneath, because simultaneous equations are all about working downwards. So I'm just going to show that with these circles here. Now for the coefficients that are the same, which is y, we're going to look at the signs. Are the signs the same or different? Well, if they're the same, we're going to subtract. If they are different, we're going to add. So the d in different is the d in add, the s in same is the s in subtract. Well, they are different, one's a plus, one's a minus, so we are going to add. And we're going to find the sum of these. So 6x plus 3x is 9x. 12y plus minus, which is just a minus, so it's 12y minus 12y is 0, which was the whole point of adding, to get rid of those y's. And then 60 plus minus, which just means minus 42, which is going to be 18. Then we just go quickly solve that by dividing both sides by 9. And we get x equal to 3, or 2 even. So x is equal to 2. Now we need to find out what y is. So what I'm going to do is I'm just going to copy out the first equation, but I'm going to substitute in the value of x, which is 2. So we've got 2 times 2 plus 4y equals 20. Again, put my solving lines in, because the first thing I'm going to do is take away the 2 times 2, or take away the 4 from both sides. So we've got 4y equals 16, and then we just go divide by 4 both sides. So we get y equals 4. And we can check that with the second equation by substituting in the values of x and y. So 3 times 2 minus 12 times 4 is equal to minus 42. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.